right, so we're still working with area of composite figures. In this case, we put our composite figure on a grid. So if you see here, it says a horizontal and vertical distance between each of the pegs on the geoboard shown below represent 1 unit. Find the area of the polygon models on the geoboard. So for this problem, I'm going to go ahead and split this up into multiple shapes. So I'm going to split it right here. I think would be the simplest. So if you look up here, we have this shape, which is called a trapezoid. And then on the bottom, we have another trapezoid. Okay, so we're gonna find the area of both trapezoids and add them together. So the formula for the area of a trapezoid, if you do not remember, is going to be 1/2. And then you add your bases together, so b1 plus b2, and then you multiply times the height. Okay, so I'm gonna go ahead and do that for both of these. So starting with the trapezoid on the top. So the area of my trapezoid is equal to, I'm going to do 1/2, and then I'm going to add my bases together. So I'm going to have to count the units. This is 1, 2, 3, and 4. So 4 units. And then on this base, it is 1, 2, 3, 4, and 5 units. So it's going to be 4 plus 5. And then we have to multiply by the height. So our height is this one right here, 1, 2, and 3 units. Remember, it has to make a right angle with the base. There's your right angle. And that would be our height. So we plug all of this into our calculator. 4 plus 5 times 3, and then we take half of that. And that gives us 13.5 units squared. Okay, now we're going to find the area of the trapezoid below. So we're going to do 1/2. We're going to have to add the bases together. So we know this base is 5 already, and then this base is only 2 units. So 1, 2. So we're going to do 5 plus 2. Now we're going to multiply times the height. So the height here is 1, 2. And that gives us a total of 7 units squared. So then from there, to find the total area of this figure, we're going to go ahead and take these two and we are going to add them together. So that ends up giving us 20.5 units squared, and that is the total area. All right, now for the next example. So on here we have, it looks like a square, maybe a rhombus. But if you notice, we cannot count the spaces of the side because they don't line up along the little peg. So we cannot figure out what this is. So the way that I am going to do so is if I count my rise, which is 3, over my run, which is 2. Do you see how I created this right triangle? So now to find this missing side, I am going to use a squared plus b squared equals, oh, whoops, sorry, I pressed something. Equals c squared. And so on here, our a is 3 squared plus b squared, which is 2 squared, equals c squared. Okay, so we're going to find the distance from here to here. And so 3 squared gives us 9, and 2 squared gives us 4. This is equal to c squared. We add them together, and that gives us 13 equals c squared. And our last step is to take the square root. So we get, I'm going to leave it in radical form. The square root of 13 is equal to c. Okay, so then this side right here, where we found it, it is equal to the square root of 13. For the other side, okay, because usually with our squares, we do base times height. So if we look here, this one is 1, 2, 3 units to the right and 2 units down, which is the exact same numbers, the exact same triangle, which means that this side is the square root of 13 also. So to find the area of this square, we're going to use base times height. And our base is the square root of 13. And our height is the square root of 13. So when you have two square root of 13s and you multiply them, it gives you the area equals the square root of 13 squared. Okay, and we know the square root and the squared are opposites of each other, right? So they cancel each other out, and that means that our area is going to be 13 units squared. Okay. All right, for the next one. It says, write an algebraic expression to represent the area of the following figures. So here, our first example, we have a rectangle. So the area of the rectangle, our formula is base times height. And so our base is 4x and our height is 2x. So the area of our rectangle is going to be 4x times 2x. And we know 4 times 2 gives us 8. And x times x gives you x squared. And that would be your expression. That's it. All right, let's look at the next one. So this one we have a triangle. So the area of the triangle is going to be base times height divided by 2. So for area of our triangle, our base is going to be 8. That's what we have as a base, and our height is k. So 8 times k divided by 2, and that is our area as an expression. All right, the next one, this is the area of a trapezoid. So the area for a trapezoid, if we remember the formula, it's going to be 1/2. We add our bases together, base 1 plus base 2, and then we multiply it times the height. So to write this, it's going to be area equals 1/2. And then our bases, one of our bases is 6p and the other is 4p. So we're going to write 6p plus 4p times our height. They have it with the letter n. This is our height. So the area of our trapezoid is equal to 1/2. When we add the bases, 6 plus 4 gives us 10p times n. And then the last step is we take half of 10. We know half of 10 is 5. And then p and n just stay like that. And that would be our expression for the area of this trapezoid. Okay, now the last section. So now we're going to write an expression to represent the area of the following composite figures. So this is a composite figure. It is made up of two shapes. Our first shape here is this rectangle. So to find the area of this rectangle, we would have to do base times height. So in this case, the area for a rectangle, our base is A, and our base is B, and our height is A, so it would be B times A. Now they have these little tally marks here. Okay, those are significant because when we're finding the area of the triangle, that is our next shape here. Since all these sides are the same, that means if this is A, then this is also A, and this is also A. So for a triangle, our triangle is base times height divided by 2. And our base and our height are both A. So A times A divided by 2. If we simplify that, that becomes A squared divided by 2. So for our total area, we add them together. So it'll be, now this one, I'm not going to write as BA. The correct way is to write them in alphabetical order. So it'll be AB. And then we add it with the area of our triangle, which is A squared divided by 2. Okay, so this is one possible way to have our answer. Now you can also have your answer if you factor out the A. So do you see how they both have an A in common? We would take the A out, and then we write what's left over. So if I took the A out from here, I would be left with this B. I don't know if you can see it. This B right here. So I'm going to write B plus, so here plus. Now, I took out one of these A's, but since it's squared, there's still an A that is left over 2. And that's it. That's another way to write this exact same thing, but the factored form. Okay, so both of these would be possible answers. If you have any questions, go ahead and leave it in the comments. If you guys need to chat, don't forget to stop by during our office hours. We'll see you guys later. Bye.